Hi, today we discuss a question of crystal packing in the terms of 2D figure. We have a question, maximum how many circles we can draw of radius 1 centimeter inside a square of 13 by 13 centimeter squares such that circles are not overlapping to each other but they can be tangential. This question is termed as crystal packing in the language of chemistry. We are putting circles in either rectangle or the squares if the figure is 2D or spheres in cube or cuboid if figure is 3D. It's just like putting atoms or molecules in a crystal. Okay, so let's start. How many ways we can put a 2D crystal packaging? Crystal packing method 1. I am taking, assume this is my crystal of length, some length. I am not putting the length. You can take any length in the horizontal or the vertical. You have a height. So okay, what we have to do, we have to put the circles inside this box. The box is closed, presume. So our first aim is we have to put maximum circles in the bottom as we can. Depends upon the length of the BC and the radius of the circles given. Okay, so we put maximum circles as we can, then just above the circles we again put the circles, then circles, again the maximum circles in the verticals. Again totally depends upon the length of AB and the radius. So this is the first method. We just put the circles in this way. But if you see in this crystal packing method 1, there is the space in between the circles. In method 2 we use these spaces by putting the crystal or the circles. Okay, let's check method 2. Our method 2 is the same crystal box. We are placing circles in the bottom, the maximum we can. Now we use these caves or the dents created by the bottom circles to put the new circles. We put new circles in the cave, then second new, then the third new, and so on. Then again we created the cave from the extreme left to extreme right. We put the new circles in this cave and the next new circles in the new cave created. So there are major two types of crystal packing in the 2D or the 3D. So let's start. If you have any question of packaging or putting circles in a rectangle or a square, first check for the method 1, bottom, then top, above, then the method 2, bottom, then in the cave, and you will get the maximum number of circles either by method 1 or method 2. Generally method 2 will give the maximum numbers of circles because we are using the maximum space here. Okay, let's start. We have a question where the square has a 13 by 13 centimeter squares. Now we have to place circles of radius 1 centimeter. We put circles in the radius 1 centimeter and so on. We can check, okay, the radius is 1 centimeter, so dia is 2 centimeter. We can only place 6 circles in the horizontal. Total is the 16, so we left 1 centimeter is the our vested space. So start with the again putting the circles like this. We can put the maximum number of 36 circles in this way because 6 horizontal till 12 centimeter and 6 verticals again 12 centimeters. So the maximum circles in this way is 36 circles. Please remember, by method 1 we put this 36 circles. If method 2 we get more than 36 circles, then answer would be from method 2. If method 2 we are getting less than the 36 circles, then answer would be 36. Okay, so start question from the method 2. Okay, we have 13 by 13 square. We are going to use the method 2 for this. Why not place circles in the bottom first? We can place 6 circles in the bottom. Okay, because the total length covered is 12 centimeter. We place 6 circles in the bottom. Then in the caves we place caves. Then we again find there is a space more than 2 centimeter. We'll check how we can find this. Then again in the cave we use the same method in the 2. Now we'll count total number of circles in the method 2. How we can find the total number of circles? We use the geometry. Okay, so check how we can use geometry in this figure. Okay, let's check how we can find total number of circles in the packaging method 2. Okay, we have circles at the bottom. We have 6 circles. Total distance from here to here is 12 centimeter. We have 1 centimeter space is not used. then we place 5 circles in the cave. Now we have to check, can we place the 6th one or not. The extreme point of the 5th circles is just above to the center of the 6th circle's bottom one. So we can say, okay, this space is 1 and from here to here total distance is 12, so we have 1 centimeter extra. So we have total 2 centimeters which can be placed. So we have total 2 centimeters, so we can place a circles in this space. So we can place 6 circles in the bottom, 6 circles just above top in the cave, and so on. So we have to find total number of circles in this method. We just join the center point of 3 tangential circles. If we join the centers, we'll get nothing but an equilateral triangle of side 2 centimeters each. Okay, because 1 1 2, and so we have an equilateral triangle of side 2 centimeter each. If we find the height of this equilateral triangles, and we know height is nothing but root 3 by 2a, and here a is equal to 2, so height is nothing but root 3 in this case. Height of the equilateral triangle is root 3, so this height is root 3. Can we say what is the, if we place only the one layer, 2 layers of the circles, so what is the total height from here to here? This height is 1 centimeter because it's a radius, yeah. This height is 1 centimeter, again radius, and the height of equilateral triangle is root 3. So total height of 2 layers is 2 plus root 3. Okay, now find the height of the 3 layers of the circles. We again make an equilateral triangle of 2 centimeters joining the circles. We again get the height is of root 3, and this height is 1 centimeter due to radius. So we have 1 centimeter top, 1 centimeter in the bottom, and the 2 height of the equilateral triangle. So height from point X to point B is 2 plus 2 root 3. Can we say, okay, we are getting 2 layers, height is 2 plus root 3. We are getting 3 layers, height is 2 plus 2 root 3. If we are getting the n layers, then height is 2 plus n minus 1 root 3. Fine. 2 layers of circles 2 plus root 3, 3 layers of circles 2 plus 2 root 3. So the n layer of circles 2 plus n minus 1 root 3, and the height is 13 centimeters. So this value is less than equal to 13. By solving this for integer, we will get n is nothing but 7. By solving this, we will get n is nothing but 7 as an integer. So we can say there are the 7 layers of the circles, and each layer has 6 circles. So the total number of circles is nothing but 7 into 6 is 42. So there are 42 circles in the method 2. So 42 is more than the 36 of the method 1. So the maximum number of circles we can place in packing 2 is 42, or in this figure we can place maximum 42 circles using the maximum space. Okay, I hope it is clear to you. We can check by the figures, can we place 42 or not. Okay, please check. Okay, let's check, can we place 42 or not. So we have started from the bottom 6, then cave 6, then again, and we have just checked there the 7 layers. So these are all these 7 layers. 6 circles in the bottom, first layer, second, third, fourth, fifth, sixth, seventh layers. So we have total is 42 circles. There are 2 questions generally they can ask, or the examiner can ask. Total of number of circles in any crystal. So there the total number of circles are 42. Then the next question, which is more important for the CAT or the SSC examination, the area wasted. If we place the maximum number of circles, then find the total number of area which is not used, like the space between the caves or the extreme left or right is how much. So it's quite easy. You have to find the total number of circles, which is 42. You have to do this, and we know the total area of this figure is 16 into 16 is 169 centimeters square, and the area of one circle is pi r square. In this case it is nothing but the pi, and the total circles are 42. So total area covered by this 42 circles are nothing but 42 pi. So the rest area is 169 minus 42 pi. So means for this question you have 2 questions: find the total number of circles and the total number of area wasted or not used by the maximum circles. Okay, if you have any doubt, you can ping me on a Facebook. The link is given below, facebook.com/mathsbyMEA, or you can write me at my email ID which is given on the Facebook. Okay, thanks.